everyone, and welcome to another episode of Investigation. In today's episode of Investigation, I'll be going over the sum and the difference rule from differential calculus, of course. So the sum of the difference rule basically states that we want to find the derivative, so dx of a function plus or minus, so sum and difference, g of x, another function, and we want to find that value. As always, we can take an intuitive sense of it. So if you have an add sign according to the limits, because derivative is defined by limits, if we have that limit, then we can just simply take it out. But we have to prove it for derivatives because there are two different stuff. So we want to assume that this is f prime of x plus g prime of x, or if you prefer, you can also write this as the dx of f of x, which basically is the same thing, but I prefer the first one because it is neater. Is it a word? Okay. d dx of g of x. And this is what we are trying to prove. Obviously, we want to take a graph intuitive sense as well. Let's say if we have a polynomial. We're just proving this for polynomials because we're most familiar with polynomials. Obviously, you can use these rules in trigonometries and other areas as well, and we will prove the general form later. So, like this, I'll just erase the not flat. So, this graph, and if we assume that there is a polynomial looks like this, let's say this is f of x, that is x cubed, and let's say there is something strange. Let's say we have, I don't know, this also works. G of x is equal to the square root of x. And obviously we just want this part of the graph because this is not defined over here. So, well, we can rewrite this as x to the 1/2 and that. So if we have this, we can calculate the derivative with the power rule. So f prime of x is equal to that's 3x squared, and this x of 1/2 is g prime of x is equal to, so that will be 1/2 x negative 1/2. And we basically just want to prove that the derivative, let's write it in red, the derivative of f of x plus g of x is equal to this thing, so 3x squared plus 1/2 x to the negative 1/2. And obviously you can write this as this if you want. Obviously that doesn't matter. So like this. And how do we prove this? Let's take a specific point. Just as I said, this is just the intuitive feel of it, and obviously we're going over the rigorous proof after. So if we have a point, let's say here, that would be like this, and if we have a point like here, that would be like this. And the sum of the functions is kind of hard to draw, so so the sum of the functions, I will draw it out. You can use a graphing calculator or anything like that, because we're not actually proving it, we're just getting intuitive sense. But make sure that every time you do that, you actually prove it mathematically and don't get relied onto computers ish. So this graph actually looks somewhat like this. So this part is kind of getting on this, and this part is just going up as the x cubed. This might not be as accurate though. So if we have that slope, we can roughly see that the sum of this slope and this slope would be the sum this slope. So let's actually prove it rigorously using mathematics now. So obviously we're still using the definition of derivatives at this point, and after this rule we're going to use the definition of derivatives for like 2-3 more rules, and then we are going to use the previous rule to prove the following rule for the upcoming rules after this first 6-7 rules that we will go over. So these rules are very important, and these are basics of derivatives. So over here we have this. We want to prove that this is just what we want to prove, so it's equal to this. And if we have this, then f, so if we take the derivative of this f of x plus or minus g of x, that is equal to, so if we have this, and then let's define a new function maybe. So this, take the derivative of that. Actually we don't need that, we just need limit as h approaches 0. Obviously you can define this as h of x and it will make it cleaner, but we can just bash it out if we want. So let's do it the cleaner way. Let's say h prime of x. So let's let this be h prime of x. So basically letting h of x is equal to f of x plus g of x. So we want to take the derivative of that. We get h prime of x is equal to limit as h approaches 0. I obviously use h, but we're using a different variable today because we already defined h. So let's just use k approaches 0 of h of x plus k minus h minus h of, that is h of x over k, and we can expand that out using our definition, you probably know. So that will be limit as k approaches 0 of g of x plus, actually we want plus or minus because it's plus or minus over here. So g of plus h plus or minus, actually we want to put f in front, right? That's our hobby. So f of x plus h plus or minus that f plus or minus g of x plus h minus that's f of x minus plus, because we actually have a parenthesis here, this is the h of x, so minus plus the g of x over k. So that's the limit as k approaches 0 of just getting this and this. So basically that would be f of x plus h minus f of x plus or minus g of x plus h, g of x plus h minus g of x over k and that would just be, so this part, as I said, using the property of limits again, so this part can be taken out to just break it up to two limits, and we can break it up this part as well. So that would turn into the limit of k approaches 0 of f of x plus h minus f of x over k plus or minus the limit as k approaches 0 g of x plus h minus g of x over k, and that would be equal to just f prime of x plus or minus g prime of x, which obviously would just be equal to this if you prefer to write it this way. I will probably not write it two ways in each video, but I will just do it for now. So this is our proof for the sum or the difference rule. Thank you for watching this episode of Investigation, and I will see you tomorrow.